Welcome back. We're going to work on lesson 4. I photocopied this and can't see what page it is. Okay, I think we're on page 192 in the textbook. So this lesson is on fractions of a set. So before we've been doing models where we've been talking about a cake or a pie or something like that and cutting the whole thing into pieces, and that's how we've been getting the pieces that we're talking about. Or maybe we've used a bar like this and we've cut it up, and that's how we've gotten our pieces. But what we're going to do today is talk about sets of things, right? So not a whole thing cut into pieces, but we're going to talk about a collection of things and how we can make fractions out of that collection of things. All right, so as we look through here at the pictures that they give us, you'll see that they're all separate objects rather than one object cut into many pieces, right? So that's really the only difference. They're just trying to introduce you to this idea that fractions don't always have to be an object cut up into things, that it could be collections of objects, and we're looking at parts of them as fractions. All right, so here's our problem. There are 8 potatoes in a basket, 6 are yellow and 2 are red. Now you might think that's weird that a potato is red. Hopefully you've seen them before. Usually the ones I see are little, like tiny little ones, versus the bigger ones that you would use for a baked potato. All right, so 6 are yellow and 2 are red. What fraction of the potatoes are yellow? What fraction of the potatoes are red? All right, so they're going to ask us a bunch of leading questions right here to get us to answer. So it says blank out of 8 potatoes are yellow. So here's our 8 potatoes, and out of the potatoes, the 8 potatoes, how many of them are yellow? Hopefully you said 6. All right, there they are right here. All right, and so what we would say is that 6/8 of the potatoes are yellow. There are 8 things in our whole set, and 6 of those things have the quality that we're looking for. All right, so 6/8 out of the potatoes are yellow. All right, how many potatoes out of the 8 are red? Well, here they are. All right, so 2 out of 8 potatoes are red, so we say 2/8 of the potatoes are red. Right, so again, it's not really all that different from what we've done before, but now these are just separate objects that make up our set. Okay, so here is another way that they're going to tell us to do this. It says out of 4 equal groups of the potatoes, all right, so if we separate them into 4 equal groups like this, all right, each set has the same type of potatoes. How many of those sets have just yellow potatoes? All right, so we see 1 set, 2 sets, 3 sets out of the 4 equal sets are yellow potatoes. All right, so we could say 3/4 of the potatoes are yellow. Now you might say, wait a minute, that's not what we just wrote up here. 6/8 of the potatoes are yellow. Well, that's okay, because let's look at 6/8 and 3/4, all right, like they do over here. 6/8, that share, they both, the 6 and the 8 share a common factor of 2. So if I take that 2 out through division, 6 divided by 2 is 3, 8 divided by 2 is 4, right? And so we still get 3/4, even though here we're counting individual potatoes and here we're counting sets of 2 potatoes, right? So then they ask us this, how many out of the 4 equal groups of the potatoes are red? So now we just have 1 out of the 4 equal groups. So 1/4 of the potatoes are red. And again, if we look at the fraction that we got here, which was 2/8, when we counted it by individual potatoes, and we reduce that, we look at the common factors, they both share a 2. So 2 divided by 2 is 1, 8 divided by 2 is 4, so this is 1/4, right? And so we get 1/4. So it's really saying the same thing. It's just here we counted them as individual potatoes, and here we counted them as pairs of potatoes. We broke it down into 4 pairs of potatoes and made sure that in each pair there was the same type of potato. Okay, next page. 193. What fraction of the animals are owls? All right, so again, we have 5 separate objects, not one object cut into 5 pieces. So 5 separate objects. Out of the 5 animals, 2 of them are owls. So we would say 2 out of 5 animals are owls. And so then we could say fractionally 2/5 of the animals are owls. All right, out of this set of 5, 2 of them have the characteristic that we're looking for, which is being an owl. Okay, now they've made a little bit different here. They've taken this set that we've had and they've duplicated it 2 more times. So here was the set that we originally had right here. Right, and now they've made that set 2 more times. All right, so maybe this is how animals live in a barn. So they've gone to 3 separate barns. So in the first barn, 2 owls, 3 bats. In the second barn, 2 owls, 3 bats. In the third barn, 2 owls, 3 bats. All right, now they're breaking that then into groups of equal animals. All right, so here's a set of 3 owls, a set of 3 owls, a set of 3 bats, a set of 3 bats, a set of 3 bats. So again, just like in the example with the potatoes, each of these groups is the same type of animal. Owl, 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 bat, 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 and so forth. All right, so out of the equal groups, how many of those groups are owls? All right, so 1, 2. All right, 2 out of the 5 equal groups of animals are owls. And so we say 2/5. What that's saying is that it doesn't matter if we just look at one barn like that, if they share that property that all barns do. It doesn't matter if we look at 1 barn or 3 barns or 100 barns, it should come out to 2/5 of the animals are owls. All right, so as long as they follow that property that in each barn there's 2 owls and 3 bats, sorry, I was not on the screen there, 2 owls and 3 bats, that it doesn't matter how many of those groups we look at, the fractional amount of owls will still be 2/5. All right, here's another question. Now, what fraction of the set of animals are bats? All right, so if we look back up here, if she asked that question, we would say, easy peasy, that's 3/5. All right, because there are 3 bats in our set of 5 animals. But here now in our sets of animals this way, 3 out of the sets of 5 are still bats. All right, this set, this set, this set are all bats out of the 5 sets. Okay, all right. Next one. I'm just realizing this is saying it's not focused, so sorry. Hopefully that wasn't out of focus. Okay, here are those chips that we've used sometimes, red on one side, yellow on the other. So they've got it so that 4 of them are turned on red and 3 of them are turned on yellow. So it says what fraction of each set of counters is red. All right, so think about that for a second. All right, so hopefully you're going to say 4 of them are red out of the set of 7. All right, so this, let's see, and we're going to write that as 4/7. So this is kind of the property that we're looking for. We're looking for redness. And this is the total number of them, whether they've got the right property or not. All right, so 4 out of the 7 chips meet the property that we're looking for. 4 out of 7 are red, and so we can say 4/7 are red. Okay, let's look at this. Now again, they've got sets of 3 chips, so we could look at it this way and say in one group there would be 3 red and 1 yellow, and the next group 3 red, 1 yellow, and the next group 3 red, 1 yellow. But then if we group them and make sets that are the same type, like they've done here, that we get red, 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 yellow, yellow, yellow. So we've made 4 sets that each have 3 chips. All right, and then it's saying how many groups of counters are red. All right, so not how many counters are red, how many groups of counters are red. So in this case, it would be 1, 2, 3 groups out of 1, 2, 3, 4. 3 out of 4 groups of counters are red, so 3/4. Okay, so in the last couple of examples, they've been making the groupings for us, but this time they're going to get a little tricky. So we need to make groups of counters, and again, our job is to make them equal groups. So I have 2 red counters here, and I'm going to group them together. And then I'm going to make another group that's the same size. But again, in each group, I have to have the same objects, all right? So it wouldn't be helpful to do red, yellow, yellow, yellow. You know, we have to make sure that we keep them the same color or that we keep the groups looking the same. All right, so this is the only way I can break them apart, where I get the same number in there and the same color in each group. All right, so how many groups of counters are red? Just 1 out of 4 groups. All right, so 1 out of the 4 counters are red. What if they asked us the question, how many groups are yellow? What would you say to that one? Hopefully you would say 3 out of 4 groups. I'm not going to write all the words, are yellow. All right, 1, 2, 3 are yellow, or 3/4 of them are yellow. Okay, let's take a look at this. So we've got 3 separate problems here. What fraction of each set is colored? Right, so again, ignore these 2 because it's not relevant. We're just looking at this. Okay, so we've got, notice how we've got 2 groups that look very similar, except they're different in one quality. Right, so here we have 1, 2, 3, 4, 5 squares, 1, 2, 3, 4, 5 squares. But this one has 5 green squares and this one has 5 white squares. So what fraction of each set is colored? In fact, in this particular case, we could say what fraction of each set is green. And so it would be 1 set is green out of 2 equal sets. So this would be 1 out of 2, or typically we would write that half, because it says what fraction, right? Not how many, but what fraction. So we're going to write that as 1/2. All right, let's look at the middle one right here. Again, ignore the top one and the bottom. I can't do both at the same time. So, and again, notice we've made equal groups, and each thing in the group is the same, except they differ by 1 characteristic. So here it's 2 circles, 2 circles, 2 circles. That's what they all have in the same. But the characteristic that's different is that these are like a teal color, white. All right, so we're looking for the colored ones, so the teal ones. All right, so we get 2 out of the 3 equal sets are teal. So we would say fractionally, that's 2/3 of the sets are teal. Okay, last one. So again, look at how they're the same and how they're different. So they all have 3 triangles pointing up, down, up, down, up, down, up. The order is not that important, but just it's 3 triangles, 3 triangles, 3 triangles, 3 triangles. And the thing that differs is it's yellow, 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 white. So they're looking for what fraction is colored. So we're looking for what fraction is yellow. So 3 out of the 4 sets, so 3/4 are colored. Okay, and again, normally before when we looked at 3/4, we would have had a whole thing and we would have cut it into 4 sets and we would have shaded like that. Never even thinking that maybe these sets of things contained something. We would have just looked at this box, and there wouldn't have been anything drawn in it. All right, so it's a lot like what we did before, but now we're drawing patterns inside each of these boxes to say that it's not just so easy as like a slice of cake. Maybe in this slice of cake, there's, 3 candies piled on there, 3 candies. So we're looking at the sets. Okay, and the last page here. There are 8 toasters in a store. 6 are purple toasters and 2 are yellow toasters. I have never seen a purple or a yellow toaster before. What fraction of the toasters are purple? So there's a couple different ways that we could do this. So we could look at it as a whole set right here and count how many toasters are purple. So we would say 1, 2, 3, 4, 5, 6 out of 8. All right, and then what fraction of the toasters are yellow? 2 out of 8. Or we could do like they did in the other problems and say, well, let me make equal groups of them. So I'm going to make one group of 2 toasters that are the same color, both purple, one group of 2 purples, one group of 2 purple, one group of 2 yellow. And now I'm going to be looking at this as 4 sets of 2 toasters. So when we say what fraction of the toasters are purple, I would say 1, 2, 3 out of the 1, 2, 3, 4 sets, 3/4. And here, what fraction of the toasters are yellow, I would say 1 out of 4. All right. Now, if I compare these, if I find the common factors in 6 and 8, it's a 2, and reduce, I end up with 3/4. If I find the common factor in 2 and 8, it's 2, so this would reduce to 1/4, and we get the same thing. So again, individually, I'm counting them, and I get 6 out of 8. Grouping them together kind of acts like reducing because it's taking them and pairing them together, and that takes out kind of that 2. It groups the 2 of them together. All right, so either way is fine, but if you do it this way where you count them individually, you do have to reduce it. All right. Okay, we do our first one with no pictures. All right, so there are 100 oranges at a market. So imagine 100 oranges. 25 of them are mandarin and the rest are navel. All right, so what fraction of the oranges are mandarin oranges? Hopefully you said 25 out of 100. All right, now I noticed that 25 and 100 both have a common factor. You might not notice the same one I do. All right, I noticed that 25 goes into both 25 and 100. And the reason I'm thinking that is because of money. When I count money, this 25 to me in my brain signals a quarter, and there are 4 quarters in 100 cents or in a dollar. So I would say 25 divided by 25 is 1, and 100 divided by 25 is 4. So this would be 1/4. You might have noticed 5, which is fine. You would just have to reduce twice. 25 divided by 5 is 5, and 100 divided by 5 is 20. All right, so we would get 5/20, and then we would have to do it again because 5 and 20 still share another factor of 5. This would end up being 1/4. So if you don't take out the biggest thing, that's fine, but it just means that you have to reduce more than once. Okay, then part B, what fraction of the oranges are navel oranges? Okay, so let's go back here. If 25 of the 100 oranges were mandarin, how many navel oranges are there? Now, if you're not sure, you would say, all right, I already used up 25 of the 100, so whatever's left over after I subtract is going to give me the navel oranges. So this is going to become a 9, and then 10 minus 5 is 5. So 75 are navel oranges. All right, so what fractions are navel? 75 out of 100. All right, again, I'm going to think money because 3/4 is 75, 4/4 is 100. So I'm going to take out a 25. There are 3 25s in 75 and 4 25s in 100. So this would be 3/4. But again, you could do the 75 and 100, divide that by 5. I know that's 20. I think this is 15. Oh, I'm going to sneeze. Bless me. And then I would do it again. They both share a common factor of 5. So this would be 3/4. All right, and just in case you forgot, she said write your answer in simplest form. Okay, good luck with the problems. I'll see you guys later.